Hello students, welcome you all to IIT Medical Academy. Today I am going to give the syllabus clarification of 11th and 12th, at the same time NEET and as well as JEE syllabus and as well as weightage also. So let's see here, we are going to discuss about the total 6 parts of physics in 11th and as well as 12th according to NCERT based. So here the first 3 mechanics, heat and thermodynamics and waves and oscillations we are getting in 11th standard. Mechanics, heat and thermodynamics and waves and oscillations according to the NCERT pattern we are getting in the 11th standard. And electromagnetism, modern physics and optics we have in 12th, 11th these 3 parts and 12th these 3 parts. What are the topics we have inside and what is the weightage of that? That's also we'll see here. So generally I am giving, generally it's not fixed, it may be 5% of the variations. So here in the all over paper, if you consider these mechanics, we are getting around 25% of the, we are getting in this 11th standard and as well as 12th standard. So here we are getting all over the paper 25% of the questions, 20 to 25% of the questions we are getting from here. 20 to 25% of the questions we are getting from here. In electromagnetism also 20 to 25% of the questions. It may be 3-4% more also. 20 to 25 means from mechanics and electromagnetism only we have 50% of the questions. From mechanics and as well as electromagnetism only we have 50% of the questions. And heat and thermodynamics we are getting 10 to 15% of the questions. Heat and thermodynamics and as well as waves and oscillations. Remaining we are getting from here this percentage maybe 10 to 12 exactly if you are going, and this is also 10 to 12% of the questions we are getting. 10 to 12% of the questions we are getting from there. And modern physics around we are getting 15% of the questions from modern physics and 10% of the questions we may get from optics. So this is the overview of the total syllabus. You can maybe increase this 25 to minimum 20%, maximum 25, and it may be 26-27% also. So like that we are getting here in NEET and as well as JEE weightage. So this weightage is not always fixed. It may be fluctuating. Generally, I am giving very generally. Now, what are the topics we have inside this? In mechanics, what are the topics we have? In heat and thermodynamics, what are the topics we have? Waves and oscillations, what are the topics we have? This belongs to 11th. So, first of all, what are the topics in 11th standard? First, see here. The first topic is physical world. Actually, it is a negligible topic because they are giving out the introduction of the physics, everything what we are going to study. So, the first topic is units and measurements. Units and measurements. The first topic. And the second topic is the motion in a straight line. Motion in a straight line. The second topic is motion in a straight line. And third topic is motion in a plane. Motion in a plane. Fourth topic is laws of motion. Laws of motion, fourth topic. And fifth topic is work, power, energy. Work, power, energy. And sixth topic is system of particles. System of particles and rotational motion. Rotational motion. Topic name lengthy. And next gravitation. Next mechanical properties. Mechanical properties of solids. And at the same time mechanical properties of fluids, solids and fluids. And the next 10th topic is thermal properties of matter. You can do one thing, we'll make it solids and fluids. Next topic is thermal properties of matter. Thermal properties of matter. And 10th topic is thermodynamics. Thermodynamics. And 11th topic is KTG, kinetic theory of gases. And 12th topic is oscillations. And 13th topic is waves. So these are the total topics of 11th. So actually total 15 topics are there, but here we are taking physical world topic in mixed in the units and measurements, and mechanical properties of solids and fluid I am considering like a single topic. What we are going to discuss about in this each and every topic, so just I am giving an overview of that. In units and measurements, what we are going to discuss? We are going to discuss about what are the fundamental physical quantities, what are the derived quantities, what are the dimensions, what are the errors means to measuring the measurements. So that means in our regular life, the measurements are very, very important. All we are using from our day starting to before going to bed, we are using the measurements. Best example, time. We are always using the time. What's the time now? Yes, I have to go somewhere. I have an appointment. Means appointment like so wherever you are taking that measurement is important. That importance of the time, importance of distance, importance of mass. What are the importance of the units and measurements that we are discussing in this topic of units and measurements. Next topic is motion in a straight line. Motion in a straight line. Here what we are going, every topic is interlinked. Physics is one having one wonderful thing. Everything we can interlink to our regular life. So motion in a straight line. In this topic we are going to discuss in this what is speed, what is velocity, what are the equations of motion, how we are applying the equations of motion. So means what is the equations of motion, what is the acceleration. So that we are all discussing in this only. And also freely falling body, vertically projected body. What is the maximum height and what kind of questions you can observe. Any object we are projecting upwards, after some time it is coming back. Why it is? Up to what height that can able to go? With what velocity we have to project? That's all we are discussing in this condition. Next, motion in a plane. Plane means in the first condition we are only able to project vertically upwards. In a plane we can also projecting the body with some angle. Best example, we are if you are a fielder in cricket field, so then you have to throw the ball not vertically upwards. If you are throwing vertically upwards, then you only catching that. So you have to throw particular angle. So that's we are discussing in motion in a plane, about the projectile motion, and also relative velocity. About the relative velocity also we are going to discuss about here. And next, laws of motion. In laws of motion, what we are going to discuss about? We know that three laws, Newton's three laws we are applying in. Now I am walking on the floor because action. I am walking, action, and floor gives reaction. If floor is not able to give the reaction, I am not able to walk. Action, reaction. Newton's third law. Newton's first law. Every body continuous state of rest, uniform motion, unless external force acting on it. Means generally you can take any body you are placing at a rest condition, that must be equal balancing force. What are that there? Friction, holding the objects. So that's we are all discussing in this topic about the friction. How the friction is important in our life. Physics, it is important in our life. So importance of that friction, and as well as types of forces. What are the types of forces? We have all types of forces, friction. That's we are discussing in laws of motion. Next, work, power, energy. We need to do the work. You need to do means you have to have some energy, and then only you can able to show your power. Yes. So that we are discussing about work, energy, power in this work, energy, power topic. Next, system of particles and rotational motion. System of particles. System is nothing but I am considering this object. I am not able to, I can hold the object at the middle. But why I am not able to holding here? Yes, because there is a something here, unknown center. That center is nothing but center of mass. So that we are going to discuss here. Center of mass. Center of mass, and as well as rotational motion. Rotational motion. Why we are not able to open the door when you are applying the force at the axis. At the axis. Nothing but you are opening the door where you are applying generally the force. We are applying the force, it is the fixed, then you are applying the force here. Here we are not applying, you are not able to apply it. What is the reason? That's everything we are discussing here. And also, what is the importance? Why you are able to balance the bicycle during the motion, but you are not able to balance the bicycle when which is at rest condition. When which is at rest condition, you are not able to balance. When which is in motion, then you can able to balance. What is the reason? That everything we are discussing here. Next, very important, gravitation. Gravitation means this is a very important and helpful to nowadays. What we are doing? We are studying the weather by using our satellites. With what velocity we have to project the satellites, and how the satellites are moving, and with what velocity they has to rotate, with what velocity you have to throw the object to escape from the another surface. So those are escape velocity, orbital velocity, that everything we are discussing in gravitation topic. Next, solids. Solid. How the solids are expand. What is the meaning of expansion? What is the meaning of expansion? Solids. So increasing of side. What is the reason? That's we are discussing in mechanical properties of solids. Fluids, liquids. We know that if you are dropping one stone and as well as one wooden piece of same mass into the water, stone is sink, but wooden piece is floats. What's the reason? And also we know that very important, aeroplane is flying with what principle? And if you switch on the fan, the papers of the calendar is rising. What about? So means what's the reason? That's we are all discussing about in fluids topics. Next, thermal properties of matter. In this what we are going to discuss about temperature. Now we are measuring our temperature. What is the temperature? How we can able to measure the temperature, and how we are using the energy conversion, heat energy, how the heat energy can be converted, how the objects are melting. For example, if you're taking ice piece, just put in your hand, that is melt. How it is happens, due to what reason? So that's we are all discussing in here. And also about radiation. What is radiation and how it will be act? And one more thing, why the animals are curling their bodies like this? Curling. Generally in winter season, the animals are not sleeping like this. They are curl the body. What is the reason? That's we are discussing in mechanical properties of matter. Next, thermodynamics. In thermodynamics, what we are discussing? Thermal laws, thermodynamics laws. What is the pressure? What is the volume? How the pressure cooker works? Pressure cooker works. Nowadays, everyone is using the pressure cooker. And whenever you can see that pressure cooker vessel thickness is more than normal vessels. What is the reason? That everything we are discussing in thermodynamics, and as well as KTG, how the bodies are moving, one atomic, one dimensional, monoatomic, diatomic, triatomic, that we are all discussing in KTG. And oscillation, time period, and what is the time taken by the pendulum, and what about the pendulum, how it will be varies from place to place. That's we are discussing in oscillation topic. And waves, and here only we are discussing about resonance. So what is resonance? And waves topics, sound waves, stationary waves, and what is the cause of reflection and Doppler effect. That's we are all discussing in waves topic. This is the total 11th topics. In this 1 to 7 topic we can take in mechanics. And 8 to 11 topics we can take in thermal properties of matter. And these 2 topics means at that time you need to change this percentage. This is you can do 15% and this you can do 10%. I'm adding these topics to here. So 15% of the questions from here. and 10% of the questions is from these two topics, waves and oscillations. So this is simply about the total 11th. And what are the topics we have in 12th? Let's overlook it. In 12th, first electromagnetism. We have electrostatics. Electrostatics. Next, current electricity. Next, magnetic effects. Magnetic effects of electric current. Next, magnetism and matter. Next, EMI, electromagnetic induction. And then AC, alternating current. Dual nature of matter and radiation. Next, atoms and nuclei, semiconductors. EM waves, communication, EM waves and communication systems. Wave optics and ray optics. These are the remaining all topics in, actually these are also 15 topics. Electrostatics is 2 topics, but I am giving like a 1 topic. And this atoms, nuclei 2 topics, I am giving 1 topic, means 14. And here EM waves, communication is the different topic, I am giving 1 topic. If you are taking total 15 topics, these are. So what are the parts here? Electrostatics. Electrostatics means we are discussing about the charges, positive charges, negative charges, how those are moving, how the forces is existing between them, what is electric potential, what is the capacitance, what are the condensers. We are using the capacitors in the circuit. Nowadays we are not staying in home without light, without power. So that's everything is interlinked from this capacitor, how the capacitors are work and what's the purpose, what is electric field, what is electric force, what is electric energy, electric potential energy. That's all discussing in electrostatics topic. Current electricity, yes, in the name only is there. This is electrostatics. If you are taking this, we can say that electrodynamics. Electrodynamics, static means charge at rest, dynamics means charge is in motion. That's we are discussing current electricity. When the charge is flows, what happened? Current. Without current, now we are not able to do anything. We are not able to spend even 1 day without current. Without current, we are not able to spend. We are not working, mobile not working. Sorry, mobile means charge. We need to charge. For the charge, you require the power. And everything. What are the appliances you have? Not working. You are not able to stay without fan. You are not able to without AC. Whatever. That's everything is interlinked with the current and how the current is flows and how we are resisting the current, resistors, about the resistor, how the current generates the heat, how the energy, electrical energy converted into heat energy. That's we are all discussed in current electricity. Next, magnetic effects of electric current. How by the magnetic effects, how we can produce the current, magnetic fields, and how it will be works out. If it is the wires are solenoid, toroid, that's all discussing in magnetic effects of electric current. Next, magnetism and matter, how the earth magnetism will works, how the magnet will works, why the magnets north poles are repelling, south pole and north pole are attracting. If you are placing the magnet, how this can shows our directions, and those all we are discussing in magnetic effects, magnetism and as well as matter in EMI. So in magnetic effects, whatever we are using, that we are taking induction of current, how we can able to induce the EMF, how we can able to induce the current. And this principle only we are using in bullet trains. To top the bullet trains, we are using this principle only. We are producing the reverse magnetism, reverse magnetic effects. That's only called as eddy currents. That's we are discussing here, eddy currents. And AC, not air conditioner. This AC is alternating current. We have two currents, direct current and alternating current. And here only we are going to discuss about how the transformer works, That's what discussing in ACs. So these all topics are comes under electromagnetism. From where to where? From 1 to 6. Electromagnetism. Next, dual nature of matter and radiation. 2 up to 10 we are named as modern physics. Why is named as modern physics? Whatever nowadays we are using, those all this is our recent physics. That's why it's called modern physics. We are taking photoelectric effect, and as well as de Broglie's wavelength. What is the importance of the photoelectric effect? How that we can able to use the photoelectric effect properly, Compton effect. So those are we are discussing. Rutherford alpha scattering. Those are all we are discussing in this dual nature of matter and as well as radiation. Next, atoms. What is atom? How the electrons are revolving in the atom? What is the hydrogen spectrum? That's all discussing in atom. And continuation, nuclei, very important nowadays. About the nuclear power we are using, nuclear weapons, how those are working, what are the radioactive elements, what is the radioactive elements, how those are working, those are all we discussing in nuclear. And what is the half-life time, and how we can find the age of the fossils. That's all we are discussing in here in this replay topic. Next, semiconductors, very important. What are semiconductors? What are PN junction diode? What is the junction diodes? What is the transistors? How those are works? And what is the LED we are using nowadays? Everyone LED lights. How those are? That's we are discussing in this. Next, electromagnetic waves and electromagnetic spectrum. What is the electromagnetic spectrum? What are the rays we are using? Right. Nowadays we are using the X-rays to detect what are the bone fractures are there. That's we are taking in electromagnetic spectrum. Communication, very important communication. How the communication is working, how the modulation, and what are the frequencies, and what is the height of the tower to get the best signal. Nowadays, without that, we are not able to see. Next, ray optics, reflection, refraction. That's all. What is that? How the lenses are working, how the mirrors are working. That's we are all discussing in ray optics. Wave optics, interference, diffraction, polarization, and also Doppler effect. How the blue shift, what is the red shift. That's we are all discussing in wave optics topic. And these two are comes under optics. This is 7 to 10 or modern physics, and last is ray optics and wave optics. It is the simply overview of 11th and 12th total physics we are going to study. First of all, we have one feeling of that physics is difficult. No, actually that's our feeling. Just you have to, once if you are started to love the physics, then physics is going to be very easy. So we'll meet and we'll discuss one topic one by one very detailedly. So we'll see the syllabus of the 12th. Electrostatics, current electricity, magnetic effects of electric current, magnetism and matter, EMI, electromagnetic induction, EMI, AC, alternating current. These 1 to 6 topics are comes under electromagnetism part. These 1 to 6 topics are comes under electromagnetism part. Next, dual nature of matter and radiation. Dual nature of matter and radiation. Atoms, nuclei, semiconductors, EM waves, and communication system. Means from 7 to 12. These topics are comes under modern physics. These topics are comes under modern physics. This is also comes under modern physics only. And this topic is comes under optics. So here, if you are observing in 11th and 12th, we have 50%, minimum 50% of the weightage from 12th. Minimum 50%. Every time, that is constantly. But sometimes we are getting more than 50% also from that 12th topic in NEET and as well as JEE examinations. So we will discuss and about in depth chapter by chapter.